right, I'm sorry about that. I don't know what happened. The computer just completely shut off on me. And I thought I completely lost the video. Fortunately, it did save it. I had to restart the computer and all that. Anyway, let's continue. Once again, I'm sorry about that. So where were we? I was showing you. This is the xz or yz plane because I set x equal to 0, and sure enough what you see is a circle. Circle didn't extend, that plane didn't extend quite enough. Oh, yep, now you will see that circle. Hopefully see that circle. mm, that's the one that we are talking about. Okay, uh, instead of how should I put it, I'm trying to show you this, uh, but if you can play with it and do all kinds of things like that, you will gain a much better idea. What is this now? Okay, so that's the plane, and that's the dotted circle that you see. That's the intersection that we're talking about. Okay, all right. So that's for that problem. Let me go back to the PowerPoint and try to wrap this up. Where were we? The previous one was, yep, it doesn't intersect. Ooh, maybe I should have shown you that. Oh, no, 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 no. Wake up, Samuel. Okay. Um, which one is the XZ plane? You see this, I told you that the red is the RGB, right? Red is the X and blue is the Z. XZ plane. Notice how this does not intersect the XZ plane, the sphere. That's what our math also pointed out, right? So that's the cool thing. That's one of the things I wanted you to see. Okie doke. One last problem, I think, if I can show you, I'll be done. Okay, what's this about? Show that the equation represents a sphere and find its center and radius. Huh. So they gave us this equation and they're saying, hey, figure out really whether this represents a sphere or not. How do we do that? Well, the thing is, we can answer that question based on, can we represent this as x minus some x1 the quantity square, x minus h the quantity square plus y minus k the quantity square plus z minus l the quantity square equals r square? Can we write this equation in that form? If we can, with r being positive, we are in business. So that's the whole idea, right? And for that, we may need to do completing the square. I hate that, man. I know. But you'll be pretty happy to see that it's really not that difficult. I'll walk you through the steps. Okay, completing the square is piece of cake. Nothing to it. Wait, this is the given equation. Ah, no, this cannot be the equation of a sphere, right? Because notice, if we expand x minus h the quantity square, you get x square minus 2hx plus h square. So the coefficient of x would actually be 1. Similarly, the coefficient of y would be 1. Y square would be 1. But here the coefficient of x square is 3. Uh-oh, so this is not. No, don't jump to that kind of a conclusion right away. Because who's stopping us from dividing throughout by 3? In that case, the coefficient of x square, y square, and z square will be 1 as required, right? Okay. Question from my side. What if this were to be 3x square plus 4y square plus 3z square? In that case, you can be guaranteed it is not a sphere. So all the coefficients of x square, y square, and z square must be exactly the same, in which case we can divide by whatever that coefficient is, as long as it's not 0, and work with it, right? Okay, so that means we can write like this. Uh, well, what's the next step? Well, bring all this 2y and 4z to the left hand side, which means manipulate, subtract 2y and 4z and arrange them like this. Okay, let's examine them carefully. Is this x square in the form of x minus h, the quantity square? Yeah. Well, y square, uh, wait. Y minus k, the quantity square, when we expand that, we should get a y square minus 2ky plus k square, right? So the important thing is that 2ky term. Oh, there is a 2y, that y term also. There is no x term by itself. There's an x square, but there is no x by itself. So that means we can think of this x square as x minus 0, the quantity square. That's not an issue. And we have a y square minus 2y. Ooh, if only we can complete the square, then we can write this as y minus some k, the quantity square. Similarly, z square minus 4z, if we can complete the square, we can write this as z minus l, the quantity square. There was no such need for x square. We could just simply think of it as x minus 0, the quantity square. Because, like I said, there was no x term. Okay, that's what we'll do. But to complete the square on this y square minus 2y, how do you do it? Very simple. The coefficient of y is what? Negative 2. Always take the coefficient of that linear term, which means the y, or if we are looking at x, just the x term. The coefficient divided by 2, the quantity square. Whoa. Let me repeat. Coefficient of y, negative 2, divide that by 2 and square it. That's what you add and subtract. Why do you do that? To compensate for the addition. You cannot just add whatever you want. So as long as you compensate for it by subtracting that same term, you are good, right? So that's what you do. So let me repeat. To complete the square, just like I said, negative 2, the coefficient of y is negative 2. Negative 2, the quant over 2, divide that by 2 and square it. That's what you add. Immediately be sure to subtract it to compensate for that addition. Now let's see. For completing the square on z square minus 4z, you do precisely the same thing. Coefficient of z is negative 4. So add a negative 4 over 2 the quantity square and subtract that. Okay. Now what you probably learned in high school or someplace to complete, add the same thing on both sides, they say. Yes, that is true. But what happens is sometimes you may not have two sides. You may have only one side. That's why I like just taking care of it on one side alone. That way, if there were to be not to be another side of an equal sign, no big deal. We can still complete the square. When we do this, why are we going through this process? We are doing this because now the first three terms automatically become a perfect square. What perfect square? Y minus 1, the quantity square. Where am I getting that minus 1? Negative 2 divided by 2 is negative 1. So this turns out to be y minus 1, the quantity square. Which one? The first three terms alone inside the square bracket. And minus, this is negative 1, the quantity square. So minus 1. What would these three become? That becomes z minus 2, the quantity square. Okay, z minus 2 the quantity square. Negative 4 over 2 is negative 2. Negative 2 the quantity square is 4. So minus 4, positive 4. So x square plus, like I said, y minus 1 the quantity square, and here z minus 2 the quantity square. We will have a minus 1 here, which I'm adding on the right, which when I add 1 to both sides to get rid of that minus 1, I have this plus 4, and we already have a 10 thirds, and that adds up to 25 over 3, and that's, ladies and gentlemen, now is this in the form of x minus h the quantity square plus 1 minus k the quantity square plus z minus l quantity square is equal to r square? Yes, it is. So what's the center? Center is 0, 1, 2. Radius, square root of 25 over 3. We can write that as 5 times the square root of 25 is 5 divided by square root of 3. And because mathematicians somehow freak out whenever they see a radical in the denominator, let's please them. You know, as engineers, we tend to please mathematicians all the time, right? 5 square root of 3. Multiply both the top and the bottom by a square root of 3. So that can be expressed as 5 root 3 over 3. Cool. So these are the kind of problems that you need to solve. Download GeoGebra and play with it. And I think that completes this section, folks. Thanks.